Good afternoon, everyone. Today I bring you a tutorial where I want to teach you concerning sets in mathematics. So whichever code of mathematics that you are using, this is the type of set theorem that you'll be learning. So whichever book of mathematics that you are using, I don't know the books you're using, but make sure that at least it's got some of these things and you'll be able to learn well. Now, without even wasting much time, let's go into what we are to do. So, what is a set? Now, a set is a collection of well-defined objects. So we all know this definition of a set. It's simply a collection of well-defined objects. Now, a set is denoted by big letters, e.g. A. Or you can have big letter B, or you can have big letter C. We use big letters to simply denote a set. Now, its elements are denoted by small letters. So if you have a set, for instance, set A, that set A may contain something in there. Now, if set A is containing letters, then automatically those letters must be written in small letters. Now, if an element A is in set A, we write A is a member of this. Okay? So what this simply means is that A is simply contained inside set A. This is a member of. We all know this. Now, if an element A is not in set A, we write A is not a member of this big letter A. This one is simply an element. This one is a set. Okay. Now, there are methods that we use for describing sets. There is the first method, which we simply call the roster tabular form. Now, the roster or tabular form is simply where if you've got a set A and you've got elements in set A, then those elements must be written in such a way that there are commas in between them so that they are separated, they are being independent. Okay, they are being well defined in such a manner. So as we can see, we've got the vowels, and these vowels are separated by commas. This is what we call the roster tabular method. We've got a set builder notation. Now, in set builder notation, we simply, if for example, we have a set A, and then let's say in that set A, there is a given a set of numbers. Now, that set of numbers must be written in such a way that X is such that X is an even number where X must be greater than 0. So we are simply using this language, and you must be able to be familiar with the language that has been given. Now, we've got different types of sets. There are two types of sets. There is what we call a finite set, and there is what we call an infinity set. Now, finity simply means it's got an ending, and infinity simply means it's got no ending. Now, we have an example. Let X be the number of the days of the week. Now, we all know that in a week, we have Monday, Tuesday, Wednesday, Thursday, and Friday, right? And Friday, right? We also have Saturday and Sunday. So these are countable. You are able to count them, right? So therefore, we say that this set is simply finity. So we say that X is a finity set. Now, let Y equal to this set. Now, this is a set of some values. Now we all know that numbers have got no ending. So we can simply put the dots to simply show that this thing can be continuous. It can go up to somewhere where we don't know. Now what type of a set is this? This type of a set is simply what we are calling as an infinity set. Okay. Now, let us look at the cardinal number of infinity set. When we say a cardinal number, what exactly are we talking about? When we say cardinal number, what exactly are we talking about? Now, the number of elements in a set is the cardinal number. It is denoted by n open bracket, the set to be defined, then closed bracket. Now, we have an example. Consider the sets A is equal to this set here, and B is equal to this set here. Now, we have been asked to find the cardinal number of this set. Now, for the first one, we are going to say that n of the cardinal number of set A is going to equal to. Now, this is very simple because I'll just count the number of elements in this set. So this is 1, 2, 3, 4, 5, 6. Therefore, the cardinal number is simply 6. We come to B. N, B. What is the cardinal number of B? We just count the number of elements, 1, 2, 3. Therefore, 3 is the cardinal number of set B. We come to the empty set. Now, from the term empty, we know that we are simply dealing with a set that has got no defined elements inside. Now, a set which contains no elements, it is denoted by the symbol, this guy here, or you may simply write brackets with nothing inside. This is simply an empty set. You are simply showing someone that there is nothing in this set. Therefore, it is an empty set. Now, note that the empty set is considered to be finity. In other words, it has an end because there is nothing there. That is just the end. There is nothing in there. So it is considered finity, and it is a subset of every other set. Now, I put lines here because I really want you to get these statements because you'll be able to use them. Now, we have an example here. They are saying, let A equal to x is such that x squared is equal to 9, such that x is equal to an even number. Now, for the first question, they want us to find or to define this set. Now, let me solve this one. I know that x to the power 2 is equal to 9, right? If I was to find the square root of this guy, I would discover that my answer is going to be 3 or -3. But then the condition is that x must be an even number. Now, because x is not an even number, I will simply say that the set A, by definition, is simply an empty set. Like this. B. Let B equal to x such that x is equal to people in the world older than 200 years. But then I know that no one has ever lived more than even 150 years this time around. It's impossible. It's just a wish that is impossible. Therefore, set B happens to be an empty set. There is no statement there. There's nothing to put in there. Therefore, it is an empty set. We come to a singleton set. Now, from the word single, we are able to come up with meaning. A singleton set is simply a set containing only one element. One element. There's only one element in this set. If you are single, you are saying you're not married. You don't have a partner with you. You are alone. Therefore, this is what we are talking about. Now, we have an example here which is quite beautiful. Let A equal to B equal to this set, where this set simply contains 2, and B equal to where this set simply contains 2, 3, and 4. Now, you must be able to understand that set A is a singleton set because it only contains one element, which is 2. And the set B is not a singleton set because it contains about 3 elements. Subset and superset. If set A is a subset of set B, what we are simply saying is that then equivalently set B is a superset of A. So if set A is a subset of set B, what we are simply saying is that whatsoever entity that set A contains is going to be found in set B. Then equivalently, if we are to take it vice versa, then we simply say that B is going to be a superset of A. Now this can be written in this form. When this thing faces this side, you are simply saying that A is a subset of B. When this thing faces this side, or if you start with B, then you are simply saying that B is a superset of A. Now, A is a subset of B if every element of A also belongs to B. For example, here we have an example. Set A is equal to this, and B is equal to this. Now we've got AB in set A, we also have AB in set B. Then what we're simply saying is that since what is in here is also in here, then set A is a subset of B. And B is simply a superset of set A. This is simply what we are saying. Equal and equivalent sets. Now, two sets A and B are said to be equal if every element of A is a member of B and every element of B a member of A. We therefore write A is equal to B. Now we put an equal sign to simply state that whatsoever A is containing is also in B. Now if not true, then A is not going to be equal B. It means that the elements that are in A are not in set B. So this is the concept. Now we've got an example. Set A is equal to 2, 4, and set B is equal to this. Now the question is A and B equal? Are these two equal? They are not equal. Why? Because we have a 5 in set B, but we do not have any element in set A, which we don't have 5 in set A. Therefore, these two are not equal. A proper set. A set A is said to be a proper subset of set B if A is simply a subset of B. What we are simply saying here is that A is said to be a proper subset of B if every element contained in A is also in B, but there must be at least one element in B that must not be in set A. Therefore, this concept must be achieved. A can be a proper set of B, but that doesn't mean that A should equal B. A should be an equal with B in that there must be an element in B which must not be in A. This can also be written in this form. Hope you are able to get and understand. Now, set A is equal to this set and B is equal to this set. Then A is not equal B, because we have 2, we have 2, we have 3, we have 3, but in here we have 4, we don't have a 4 in here. Therefore, A is a proper subset of B, but A is not equal B. We come to the number of subset of an infinity set. Consider the sets A is equal to 1, 3 and B is equal to A, B, C, D, E, F, G. Now, if you want to find the number of subset of a set, we are simply using the formula number of subset is equal to 2 to the power n. Therefore, I will say 2. Now, n is simply some number of the elements in set A. So we are simply saying that 2 to the power 2 is going to equal 4. Therefore, we have 4 subsets in set A. When it comes to B, you can simply say the number of subsets in B is equal to 2n, right? So now this can be 2, 1, 2, 3, 4, 5, 6, 7 to the power 7, like this. Okay, to the power 7, to the power 7 like this. So whatever you find, whatever value you find, that is the answer. We come to power set. Now, the set formed by all the subsets of a given set A is called the power set of A, which is simply denoted by P, open bracket, that same set A, or 2 to the power A. Now we've got a very interesting example here. They are saying consider the sets A of this and set B of this. Now, then the subsets of set A and B are what? They want us to calculate that. Now we have A, wow, is equal to this. Okay? What exactly is going to be the power set of A? So it's going to be P A is going to equal to, you open the brackets. Now the first thing that you are going to put there is the empty set. Whenever you're writing the power set of a set, do not forget to put the empty set there, because the empty set is very, very important. The empty set is very, very. In order for us to write the power set of A, we are going to say that, remember, in the first place, I think I outlined to you people, in the first place, I showed you that you are to take care of that statement that I made concerning an empty set. Okay? There was a statement that we made in the first place concerning an empty set. Sure you remember, where we said that the empty set is considered to be finity and a subset of every other set. Now, whenever you are finding the power set, the power set of any set that you have, you are supposed to consider the empty set, because the empty set is simply a subset of every other set. So you are going to put the empty set. You can either put you can either put this symbol, or you can choose to use this one. But I'm going to use this one. So now, the power of a set A is going to be the empty set, comma, set 1, comma, set 3, comma, then I combine 1 and 2. This is the power set of set A. We come to B. Now P, the power set of set B like this, is going to equal to, you open the brackets, you first of all consider the empty set as the first thing, then you outline these letters as individual sets. A, B, C. Now, after you outline these guys together, you consider A to combine with this. A, comma, B, comma, A, comma, C. Now, when you combine these guys like this, you can now consider to combine B and C, comma, P, comma, C. This is another set. Then from here, you now combine the 3 all together. B, C, like this. Then from there, you close the brackets. So, concerning whatever I've taught here, it's very important that you be able to learn and you be able to understand the concept. Make sure that you get the concept. Make sure that you get the concept. Make sure that you are able to do these things and you are able to get to define them. This is very important as we shall be able to use it in our next session. So make sure that you follow me on YouTube. Make sure that you invite your friends, share with your friends, and we shall flow well. Okay, so let us now look at operation on a set. Okay, we look at the operation on a set. We try to do some of these so that at least you'll be able to open up. Then the next time I come to teach, I'll be able to show you how to do De Morgan's law, how to do algebraic algebraic ways of finding a set. Algebra, you involve algebra to find a set. We'll be able to do all those things together. Now, these things are things that you've learned before. You've seen them before from secondary school. I don't know. Some of you, you learned them even in from whatever 4, from 6, from 7, grade 4, grade 6. So these are simple things. We have a question which happens to be very interesting. They are saying, let the union set be this entire set here. The union set is simply the set of everything, or of all the sets that you have been given. It's more like the major set of all the individual sets that you have been given. Given that A is this set, B is this set, C is simply this set, they are asking us to list A union C. Now, A union C, union simply means uniting. We are simply uniting this family of A and this family of C together. So A union C is going to equal to whatever is in A. So we'll start with 0, comma. We have 1 in C. we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 10, then we have 12, like this. We have simply listed A union C. So this is simply A union C. Come to B. B intersection C. Now, B intersection C, intersection simply means we are simply fetching out whatever happens to be in B at the same time in C. So whatever happens to be in B at the same time in C, let's check. So in set B, we have 1, we don't have 1 in here. We have 2, we don't have 2 in here. In here we have 3, and in there we also have 3. Like this. Comma. 4, we don't have 4 in there. 5, we don't have 5 in there. 6, we do have 6 in there. Okay, so these are the only intersectory elements that are found in B and in C. Okay. We come to the other part. Hope you people are able to see what I'm doing. Now for this one, they are saying A intersection B union C. Now, since we've got brackets, we are going to use BODMAS. We'll start with whatever is in the brackets. So now, B union C is simply combining or uniting the elements in B with those in C. So it's going to be, what are the elements that are in B and in C? So we'll start from, we've got a 0 there. Okay, we've got a 1 in C, we've got a 2, we've got a 3, a 4, a 5, a 6, a 7, then we've got 12 and 15. We cross the set. Now, they are saying that this set be intersected with the set A. Okay, let me just do it fast. Now, what is found in A must intersect whatever is found in this set. Therefore, in A, we have a 0, right? In here, we have a 0. In A, we have a 2, okay? Even here, we have a 2, right? In A, we have a 4. In here, do we have a 4? Of course, we do. In here, in A, we have a 6. Do we have a 6 in here? Of course, we do. In here, in A, we have a 12, right? A 10. Do we have a 10 in here? A 10? We don't have a 10. In this set, we don't have a 10. Therefore, we won't include it in here. But when you look at 12, we have a 12 here. We also have a 12 in here. Therefore, these are the elements that are intersecting. Listen, very much simple. You can apply this same concept on this one. You simply find whatever is intersecting between A and C. Then when you find the intersection of set A and C, then you can simply find the union of B. So this is going to be your work. Let me even outline it. So this question is simply your exercise. You can send it on this line. You can text on WhatsApp. Make sure that you send me this question this week. Now, for E, they are saying A union B complement. Now, A union B complement, what these guys are simply saying here is that they want you to list the elements which are simply found in A but may not be found in B. Okay. Hope you get that concept clear. Okay, so hope you get the concept. Now, A union B complement. This is simply a complement. So the first thing that we'll be able to do, we'll be able to find B complement. Now, B complement simply means if we were to put everything together, okay? If we were to put everything together, then we remove the elements which are found in C, then what are we going to remain with? So you discover that the set we remain with is going to contain, since we've got C and A, and then we remove only we remove set B, it means that we are going to have A and C, then with together the universal set. So it's going to be 1, okay? Hope it's clear. 2, 4, 5. Please make sure that you do it slowly so that you will be able to get what you are doing. Make sure that you do it slowly so that you'll be able to get what you are doing. So then we're going to have 11 here, 13, then a 14 here. Okay, so now we have B complement. That is, we have removed the elements that are found in B from the entire sets that we have. Now from here, we have been taught that we find A union B complement. Now, in the next section, for you people that are viewing the videos in part 2, I'll be able to show you how you can write this. Okay, how you can write this. Now, this A union B is complement is just the same as this set intersecting with whatever elements that remained after we removed the elements of B, which is simply B complement. So in other words, what we are saying is we are going to write a set of A which happens to be 0, 2. Let me be fast. Okay, like this. So we've written the set. Now this set is simply intersecting with whatever we have here. Whatever we have here. That's what this simply means. So when we start doing algebra, finding sets using algebra, and identifying how you can line up the sets, you'll be able to understand what I've done here. Okay. Now, therefore, we can say A union B complement is going to equal to. Now let's find whatsoever is in here, which is also in here. So you discover that you are going to have a 2, a 2, a 4, a 4, 6, there is no 6, 10, there is 10. What else? Nothing. Therefore, this happens to be the answer. So make sure that you understand this. Here, A union B complement, just make sure that you find the complement of set B. This simply means complement, the C on top. So you are going to remove all the elements of set B from the universal set. At the same time, you also remove them from A and C. Then you combine A and C together. You also combine the universal set. You make it one set. That is what you are going to remain with. In other words, a complement simply means outside of something. So when you remove or when you cover B, whatsoever is going to remain outside, they are saying put it together and simply use it to find the answer. So hope this lesson has been good to you. Hope you've understood, and make sure that you send me this exercise on WhatsApp. I'll be responding to you. So make sure that you check up on the second tutorial, second video. Make sure that you check up on it and make sure that you respond to the questions that I'm going to give. See you guys. Thank you so much.